In this video, we're going to look at log laws. In previous videos, we've already seen two of them. For a, where a is a positive quantity, we can say that log to the base a of a is equal to 1. Let's just remind ourselves of the definition of a logarithm. The logarithm is the power the base is raised by to give a certain value. So if we write the exponential equivalent, a to the power of 1 is equal to a. We also saw that log to the base a of 1 is equal to 0. We know a to the power of 0 is equal to 1, therefore log to the base a of 1 is equal to 0. We're now going to focus on three more laws. The first one is log to the base a of x plus log to the base a of y is equal to log to the base a of x, y. So if we're adding logs when the base is the same, so in this particular case the base is a, if we're adding logs we end up now with a product. The next one, log to the base a of x minus log to the base a of y will be equal to log to the base a of x divided by y. So if we have a difference, this becomes a quotient. So if we're subtracting, we end up dividing. If you're ever struggling to remember these, just go back to the rules of indices. If we're multiplying and the bases are the same, we add the powers. If we're dividing and the bases are the same, we subtract the powers. So therefore, this is just working in the opposite way. If we have now the third one, log to the base a of x to the power of k is equal to k multiplied by log to the base a of x. So these now are three particular rules that you will need to learn and apply to certain problems. Let's just look at these first two. What I'm going to say now is the following. I'm going to define now log to the base a of x to be equal to some quantity p. So if we write now p is equal to log to the base a of x, and we say that q is equal to log to the base a of y. If we now write the exponential equivalent, we can say that a to the power of p is equal to x. So just writing this out, a to the power of p is equal to x. If we write the exponential equivalent, we can say a to the power of q is equal to y. If I multiply these two, a to the power of p multiplied now by a to the power of q will be equal to x multiplied by y, or xy. Using the rules of indices, we can see a to the power of p plus q will be equal to xy. I'm now going to write the logarithmic equivalent statement, and that is that p plus q is equal to log to the base a of x, y. If we just consider now, we have p plus q. P is log to the base a of x, q is log to the base a of y, therefore we can see p plus q will be equal to log to the base a of x multiplied by y. So let's just go ahead and write that. So we've got p plus q, so that's log to the base a of x plus log to the base a of y is equal now to the product of log, well it's log to the base a of the product x, y. And as you can probably imagine, this works too for subtraction. If at this stage instead of multiplying we divided, we could say that a to the power of p divided by a to the power of q was equal to x divided by y. If I now consider I've got the base the same using the rules of indices, we could say a to the power of p minus q is equal to x over y. Now rewriting the logarithmic statement, p minus q will equal log to the base a of x over y. So we can see now the subtraction p minus q is log to the base a of x minus log to the base a of y, and that's going to give us log to the base a of x divided by y. So let's go ahead and write that. Log to the base a of x minus log to the base a of y will be equal to now log to the base a of x over y. So that shows now that those hold true. So these now are additions for, or are rules for addition and subtraction of logs. If we add logs when the base is the same, we end up with a product. Now you might want to just write this. You might want to write log a plus log b is equal to log ab. If you want to just remember it like so, this is perfectly fine, as long as the base is the same. And we can say that log a minus log b will be equal to log, and then we'll have a over b. So those are two rules that you need to be able to use. The rules for addition and subtraction. Okay, let's look at this one. Log to the base a of x to the power of k is equal to k lots of log base a of x. So log to the base a of x multiplied by k. Now we can show it with a very similar approach to the one I've just used, and using the rules of indices. I think this is easier to show it in a more intuitive way using these particular laws. So what I'm going to do, instead of using now a similar approach to show a proof of this, what I'm going to do is take an example. If we have now, let's say we've got log, and we will have log, and I'll just use now log rather than any base. We could, of course, if we wanted, use a. In fact, we'll use a. Log to the base a of x cubed. Now, let's think about how we could write this. Log to the base a of x cubed. Well, this is going to be now log to the base a of x multiplied by x multiplied by x. If we consider now using the addition law, we could actually write this and split this up. So what we have here now is a product. We've got a product. So I could write this now as log to the base a of x plus log to the base a of x plus log to the base a of x. So all I've done is used this law of addition now to split it back up. We can see from this that we've got log to the base a of x plus log to the base a of x plus log to the base a of x, which is going to give us now 3 log to the base a of x. Now, whilst that isn't a proof and it's a demonstration with a given scenario, I think it's a lot easier to understand now why the power law, and this is what we call it, works for logarithms. Log to the base a of x to the power of k is k lots of log base a to the power of x. So all we need to do is be able to use and employ that. It's highly unlikely that you'll be expected to show it. So these now are the 5 particular laws that you need to use to simplify logs and just use them, especially when it comes to equations. I'm going to add 2 more for completeness, and the first one is log to the base a of a to the power of x is equal to x. Now this is fairly intuitive, as we can bring now the power down. So if we think we could write this as x multiplied by log base a to log base a of a, which is just going to give us x. And again, if we use now the idea that the log and the exponential are inverse functions, we can write a to the power of log to the base a of x. That will also be equal to x. Now, using and applying these is less frequent, but I've just added them for completeness. What we want to do is focus now on the use of these particular laws. So what we're going to do in this video is work through some examples and look at simplifying logs or writing them in different forms. So let's look at some of these. We're asked to express in the form log to the base a of n. So we can see here we've got now the same base. We've got base a and we're adding logs. If we're adding logs, we end up multiplying. So we could write this now as log to the base a of 4 times by 7, which is going to give me 28. If we look at this, we have a difference of logs. So we can write this as log to the base a of 10 divided by 5, which is going to give me 2. This one right here, we can now use the power law. I can reverse the power law. This is of the form k multiplied by log to the base a of x. We can write this now as log to the base a of x to the power of k. So all I'm going to do is bring this back up. We want this as log to the base a now of n. Therefore, my first move is to write this as log to the base a of 6 to the power of 2, which is going to give us now 36. So we can write this as log to the base a of 36. So the value of n in that particular case is going to be now 36. We have a difference of logs, so we need to divide these. So we're going to have log to the base a of 9 divided by 1/3. 9 divided by 1/3 is going to give me 27. So log to the base a of, and I'll write it out, 9 divided by 1/3. So we're going to have now log to the base a of 27. So the value of n is 27. Okay, with this one now, we want to reverse the power law. So in this case, I'm going to bring the power up. And I'm going to initially write this now as log to the base a of 25 to the 1/2 power plus, and reversing now the power law, I'm going to write this now as log to the base a of 3 to the power of 2. So all I'm doing now is writing these. We don't want now some multiple. So we don't want a value right here of k. We don't want a constant. I know that 25 to the 1/2 power is 5. So I can write this as log to the base a of 5. I know that 3 squared is 9, log to the base a of 9. I have the same base, therefore when I'm adding logs I can multiply them. So I get log to the base a of 5 times by 9, which is going to give me 45. So the value of n in that particular case is 45. With this one we can go ahead and split this up, and lots of different approaches. Let's just rewrite this. Let's write this now as log to the base a of 48 minus, and then I'm going to bring the power up. And I'm going to write this now as log to the base a of 2 to the power 3, which is going to be 8. And then we're going to have minus log to the base a of 9 to the power of 1/2, which is going to give me now 3. At this stage now, we can just go ahead and use our law. I'm just going to rewrite this now, and I'm going to write this as follows. So I'm going to write this as minus the quantity and add these two together. So all I've done is factor that. So if we use now the log law right here, we're going to have the following. We will have log to the base a of 48 minus, and just using now the product rule or the sum rule, we can say that this will be log to the base a of 8 times by 3, which is 24. We now subtract, so we're going to have log to the base a of 48 divided by 24, and that will give us log to the base a of 2. So the value of n is 2, and that's one approach. If you were in an exam, you would show full workings. 2 to the power of 3 is 8. 9 to the power of 1/2, and we would just use them. That's one approach. You can, of course, split that up however you like. So express in the form log to the base a of n. Okay, we're asked to express in the form p multiplied by log to the base q of x. So this time we're using the power law. So we've got a power and we bring it down. It's really important to stress at this point with the power law there are subtle differences. And I'm just going to write that out. Let's just put this here. If we have now, and I'll just use log, if we have log x squared, in general we can say that this will not be equal to log of x squared. Those are not going to be equal. Let's just look at this one. All we're going to do is bring the power down. So we'd have now 5 log to the base q of x. We've just brought the power down. Bringing the power down, we're going to have 15 over 2, or 7.5. I would prefer to leave it as a fraction, log to the base q of x. If we look at this one right here, now we can rewrite this. 1 over x is x to the minus 1. So my first move is to write this as log to the base q of x to the power of minus 1. I'm now going to bring the power down, and we can write this now as minus 1 log to the base q of x. So we've got p in this particular case is minus 1. Let's rewrite this one. This is the cube root, so we could write this now as log to the base q of x to the power of 1/3, bringing the power down 1/3 log to the base q of x. This one right here is the minus 1/2 power. So let's write this now as 4 log to the base q of x to the power of minus 1/2. I'm going to multiply down. 4 times by minus 1/2 will give me minus 2 log to the base q of x. So all we're doing now is simplifying using the rules of indices. Now with this one, I can do this two different ways. Let's just consider now if I went ahead and added these. If I went ahead and added them, and we'll look at it two different ways, log to the base q of, and then I'm going to have now the product of x to the power of 2 multiplied by x to the power of 5. That is going to give me log to the base q of x to the power of 7. So if we're adding logs, we multiply them. Therefore, bringing the power down, we would have 7 lots of log to the base q of x. Now, if we'd done this to begin with and brought the powers down, we would have 2 log to the base q of x plus 5 log to the base q of x. We know if I have 2p plus 5p, that will be equal to 7p. Therefore, 2 lots of the quantity, log to the base q of x, plus 5 lots of the same quantity will be 7 lots. So that's one way that we could do that one. With this one right here, we can do lots of different things. We could do exactly the same. Alternatively, we could write this now as log to the base q of x to the power of minus 2 plus log to the base q, and we'll write this log to the base q of x to the power of minus 3 and bring the powers down. So minus 2 minus 3 will give me minus 5 lots of log to the base q of x. Alternatively, you could go ahead and multiply those. If you multiplied them, you'd have now 1 over x to the 5th, so you'd have log to the base q of 1 over x to the 5th, which you could write as x to the minus 5. Okay, let's do this one. So let's now multiply down by the power. So what we're going to have then is the following. We're going to multiply down, that's going to give me 6 lots of log to the base q of x, and then we're going to now multiply down by the power minus 2 lots of log to the base q of x. So all I'm doing is bringing the powers down. 6 lots of a quantity minus 2 lots of a quantity is going to give me 4 lots of that quantity. So log to the base q of x, and we have 4 lots. Again, you could bring the power up. You could go ahead and bring that power up and have now log to the base q of x to the 6. You could bring the power up, and then you could have now log to the base q of x squared. So if you wanted to go for that approach, you could do. It's entirely up to you. So just remember, if you're going to bring this up now, you're going to have now the power x to the 4th raised to the 1/2. So take your time, but this is what we should end up with. 4 lots of log to the base q of x. Okay, let's look at some more. We're asked to express in the form log n. Now log is base 10. So we looked at this on a calculator before. We've got 3 choices now of log buttons. This now is log to the base 10. So if we had log to the base 10 of 100, we know that's going to be 2. As 10 squared is 100. Yet if I just put in log of 100, we're going to get exactly the same. This is base 10. Log to the base 10 of 100 is 2. So when we see now the form log n, it just means base 10. So if we consider what we're going to get now, we're just going to be adding these. So we're going to get now, and I'll write this as LG. Generally we would write log. This particular notation is less used, and then we would have now log 20. So let's go ahead and write that. 5 times by 4, we'd have now log 20. This one right here, we've got now the subtraction, so we would divide, so it would be 12 over 6. So this would be log 2. This one right here, we can bring the power up, so that would be 2 to the power 3, so we'd have log 8. So all we're doing is looking at writing this now as one lot of log to the base 10 of some quantity, and we're just finding that. This one right here, we can bring the power up and then go ahead and now subtract. Alternatively, we could write this in a different way, and I'm just going to focus on this in a very slightly different way. We could write this now as 4 log 3 minus now log, and then we would have 3 squared. 3 squared is 9. I could bring the power down. I've got 4 log 3 minus 2 log 3, and that is going to give us now 2 log 3. Now, of course, we want to write this as log n. I suppose what I'm doing here is just showing that how another way this could be written. So this would now be 3 squared. So you can see that particular approach is not now more effective to do, but just recognise that sometimes we can write this as a power. What I would do with this instead is write this now as log, and then we'd have 3 to the power of 4 minus now log, and then we would have now 9. So this would be log, and this would be 81 over now 9. So we can see that that is going to give us now log 9. So that would be a better way to do that particular question now, by simply rewriting this power. With this particular one, we could though split this up and now go ahead and use the power law. Okay, let's now rewrite this one. So we're going to bring the power up. 16 to the 1/2 power is going to give me 4. So this will be log 4 minus, bringing the power up, and we would need to show this in our working, 32 to the 1/5 power is going to give me 2. So we have log 4 minus log 2. And at this stage, again, we could just divide. So it's going to be 4 over 2, which is 2. Alternatively, less likely in this particular case, we could write this like so, bringing the power down, 2 log 2, we could write now minus log 2, it's going to be 1 lot of log 2. So again, a less effective way to write that, and I'm using brackets. You don't have to. I'm giving my final answers brackets, some of these not. Be consistent. I'm not really being consistent as such. But you can see different ways of looking at these. I would go for this approach and then just use now the quotient. So the difference of logs gives us a quotient, but as you can see, there's lots of different ways that you can manipulate these. Okay, this one is quite nice. We have now 1. Let's look at log to the base 10 of 10. We know that this is going to give us 1. What power is 10 raised by to get 10? The answer is 1. Therefore, I can write this as log 10 plus log 11. So now we've got the addition, so we can write this as log, and then we multiply the 2. That's going to give me 110. So just be slightly careful with those, but it's fairly logical and fairly straightforward. Okay, with this one right here, we have now log of 1/50 plus 2. So lots of different approaches with that one. One thing we can do is consider now that 2 is going to be log to the base 10 of 100. So this 2, if we just write this here, if I write log, now let's put it here, log to the base 10 of 100, we know that that's going to be 2. 10 to the second power is 100. Therefore, what I have here now is log of 1/50 plus 1/50 rather than 15th, plus now log, and then we're going to have 100. If I multiply 1/50 by 100, that's going to give me 100 over 50, so we're going to have log 2. And that's now 1%. particular approach. So very similar with this one, we could write this now as 1000. Okay, so that's expressing now in the form log n. Remember, you'll generally see log, and we take that to be now base 10. Log to the base 10 is the same as log, and that's on your calculator. Okay, let's look at some more. Without using a calculator, evaluate the following. So let's look at this one. We have now a quotient. If we've got a difference of logs, it becomes division, or if we like, a quotient. So I'm going to write this now as log to the base 3 of 54 divided by 2. That's going to give me 27. In an exam, we would show 4 workings. The first thing I do is write 54 over 2 to show that I know that log law. I'm just writing these down. As you can see, we've got quite a few to get through. What power is 3 raised by to get 27? The answer is 3. Remember our statement, log to the base a of b is equal to c. Therefore, what we have now is the exponential equivalent, a to the power of c is equal to b. So all I'm doing is rewriting these now in the form. So what we're going to have is 3 to the power of 3 is 27. If we look at this one now, we've got log to the base 5 of 20 plus log to the base 5 of 1.25. With this one, we can use lots of different approaches. If we multiply 20 by 1.25, we're going to get to 25. So what I'm going to do here is just write this. And again, you would show, in fact, I'll show the workings on this. Log to the base 5 of 20, and we're going to multiply this by 1.25. I'm showing that I know this particular law. So we've got log to the base 5 now of 25. What is the power 5 is raised by to get 25? The answer is 2. Therefore now, without using a calculator, I've evaluated this by now grouping these up. When we're adding, it becomes a product. Okay, this one right here, well, we can just go ahead and write numeric values. Log to the base 2 of 16. 2 to what power is 16? The answer is 4. Log to the base 3 of 27. 3 to what power is 27? The answer is 3. 4 plus 3 is equal to 7. So with that one now, I'm not going to use log laws. The reason being is that I have a different base, and I can just evaluate these anyway. So when we're using the addition or subtraction laws, we need to ensure that the bases are the same. Okay, let's look at this one. We've got now log to the base 6 of 24 plus log to the base 6 of 9. So all we would do is go ahead and multiply these. So this would give me now 24 times by 9. So we'd have log to the base 6 of 216. We could write now that 6 to the power of 3 is 216. So now we can just write the answer is 3. The logarithm is the power that the base is raised by to give us this value. Okay, let's look at this one. We've got now log to the base 3 of 12 divided by 4. 12 divided by 4 is going to give me 3. What power is 3 raised by to get 3? The answer is 1. So all we're doing is simply using these laws. This one right here, this is going to give me log to the base 4 of 18 divided by 9. 18 divided by 9 is 2. What power is 4 raised by to get 2? The answer is the half power. 4 to the half power is equal to 2. Again, if you like, you could have written at this stage, log to the base 4 of 2 is equal to some quantity x. Therefore, we can write that 4 to the power of x is equal to 2. So if you want to go for this particular approach, you can do. It's entirely up to you. So if you wanted, you could write 2 to the power of 2 raised to the power of x is equal to 2. Therefore, we could say that 2x is equal to 1 and x is equal to 1/2. So if you're struggling to kind of spot that, just go ahead and write these like so. I would suggest not, but it's something we did look at in the last video. Okay, let's do a couple more. So these ones are fairly straightforward. Let's look at this one right here. What we've got now is the power law. So I'm going to bring the power up, and this is going to give me, and I'm going to write it as log this time. It's more likely that you're going to see log. And this is going to be log of 2 squared plus now log of 25. So this is going to be log 4 plus log 25. We've now got the addition, so we're going to multiply. This is log 100, and we've got here now log, if we think about this, log to the base 10 of 100 is going to be equal to 2. We know that 10 squared is equal to 100, so log to the base 10 of 100 is equal to 2. Okay, let's rewrite this one. Bringing the power up, we're going to have now log to the base 3 of 8 to the 1/3 power. 8 to the 1/3 power is going to give me 2. Minus now log to the base 3 of 18. We're subtracting, so we're going to get a quotient. Log to the base 3 of 2 over 18 is 1 over 9. What power is 3 raised by to get 1 over 9? The answer is minus 2. Again, if you wanted to solve that, you could say 3 to the power of x is equal to 1/9. And what power gives us now 1/9? Again, you could write this as 3 to the x is equal to 3 to the power of minus 2. So x is equal to minus 2. I think that's long-winded, but it gives you some idea. Okay, let's look at some more of these. So let's just bracket some of these off. With this one right here, let's go for this one. These are much of a muchness. All we're going to do is simplify these. Let's just simplify this right now. I'm going to now write this as a mixed number. So what we're going to have is 1/2, and then we'll have log to the base 5. Now writing this as a mixed number as 25 over 16. So what we have is 25 over 16, 1 and 9/16. Plus, we're going to have 2 log to the base 5 of 10. So let's go ahead now and use the power law. Bringing the power up, this is going to be log to the base 5 of 25 over 16 to the half power. So we're going to get now log to the base 5, and I'm going to write this now as 5 over 4. That's just using now the half power. At this stage, what I can do is rewrite this one, and I can write this as plus log to the base 5 of 10 squared, which is going to give me 100. Again, I would show full workings. Now, at this stage, we've got a couple of choices. I'm looking at this and thinking I can multiply these two, so I could write this as log to the base 5 of 5/4 of 100, which is going to give me 125. Again, I would show that I'm multiplying those. So what power is 5 raised by to get 125? The answer is 3. That's one approach. I'm not for one moment suggesting there's not a slicker way or a quicker way. I'm doing these as I go, but that would seem a fairly logical choice. We could again split these up in different ways, but that is one approach that you could take. So I've rewritten these now as log to the base 5 of n rather than k log to the base 5 of n. So I've brought the power up. I've used now the power law on each. I've then used the addition law to rewrite. So that's an example of those ones. Okay, we're asked to express in the form p log to the base 10 of a plus q log to the base 10 of b. So let's see what we've got here. We have a product. Therefore, we can split this up and write it as a sum. So we can write this now, and I'm just going to write it, let's just write it as log rather than log to the base 10. So what we have then is log a plus log b. All I'm doing now is splitting that up. A product becomes now the addition. If we look at this one, we could write this as follows. We could write this as log a plus log b to the power of 7. So I could write this now as log a plus 7 log b. So in this particular case, we've got now that p would be equal to 1 and q would be equal to 7. So I'm just using those laws. Let's split this up. Log, so we'll have now log of a to the power of 3 minus log b. Bringing the power down, 3 log a minus log b. So we can see the value of P is going to be positive 3. The value of Q is going to be minus 1. So P is equal to 3. We can see Q is equal to minus 1. Okay, let's go ahead now and look at some others. This is just now B to the half power. So we could go ahead and split that up. This one, we've got a couple of choices. We could just bring the power straight down. So what we'd have now is 2 lots, and then we would have log now of AB. So all we'd have here is 2 lots of log A plus log B. So I've brought the power down, and then we have exactly the same as here. So we could say that P is going to be equal to 2 and Q is going to be equal to 2. This one right here, what we could do with this one is write this as log of AB to the power of minus 1. 1 over AB is AB to the minus 1. So what we'd have now is minus, then we'd have log AB, which is log A, plus log B. So we can see in this particular case, we could write this as minus log A minus log B. So this would now give us that P is equal to minus 1 and Q is equal to minus 1. With this one, we have a couple of choices. We could bring this half power straight down. Alternatively, we could write this now as log of A to the power of 3 over 2 multiplied now by B to the power of 5 over 2. So we could now write this as 3 over 2 log A plus 5 over 2 log B. And hopefully you can see what I've done in splitting those up. This is log A to the power of 3 over 2 plus log B to the power of 5 over 2, and we've brought the powers down. This one here, we could write this now as A squared B to the minus 1/3, split them up and bring the powers down. So express in the form P log base 10, log to the base 10 of A, plus Q log to the base 10 of B. It's just using the power law and the addition or subtraction laws. Okay, let's do some more. Given that y is equal to log to the base q of 8, express each of the following in terms of y. So let's consider what we've got here. We've got now log to the base q of 64. With this one, we can do lots of different things. The first thing I'm going to think of is writing this now as log to the base q of 8 squared. Bringing the power down to log to the base q of 8. Well, we know that y is equal to log to the base q of 8, so we can say that this is 2y. An alternative would be to write this now as log to the base q of 8 multiplied by 8. That's going to give us now log to the base q of 8 plus log to the base q of 8, which is y plus y. Again, I wouldn't want to really write it in that way, but it's an option for you. Let's look at this one. I'm going to use now a power. Log to the base q of 8 to the power of 1/3. 2 is 8 to the 1/3, so we could write this as 1/3, bringing the power down, log to the base q of 8. Well, I know that log to the base q of 8 is y, so this would be 1/3 y. So all I'm doing here is simply now rewriting these. Okay, let's look at this one and split it up. What I could do is write this now as log to the base q of 16 minus log to the base q of q. So using now the difference of logs, we've rewritten the quotient now in the following form. Let's just think about 16 as a power of 8. If I take the cube root, I get 2. If I then raise it to the 4th power, I get 16. So I could write this now as log to the base q of 8 to the power of 4 over 3. We know that log to the base a of a is 1, so we end up now with 1. This is just 1. Bringing the power down, we've got 4 over 3 log to the base q of 8 minus 1, so we have 4/3 y minus 1. And that's one approach that we could use. With that, as stated, it's entirely up to you. With this one now, I'm going to split this one up. Let's just go ahead. Let's just move over and split this up. So when you're doing these, it's often a case of thinking, how can I rewrite these? So what we have then in this one, I'm going to write this as log to the base q of 4 plus now log to the base q of q cubed. That's a bit of a mouthful. Okay, let's look at this now as a power of 8. We'll take the cube root and square it. So I can write this as log to the base q of 8 to the power of 2 over 3. Bringing the power down, I'm going to write this as 3 lots of log to the base q of q. We know log to the base q of q is 1. What power is q raised by to get q? The answer is 1. So we get 2 over 3, bringing the power down, log to the base q of 8 plus 3 lots of 1. This is y, so we get 2/3 y, and then we're going to have now 2/3 y plus 3. So we've expressed now these in terms of y, and it's just splitting them up. And again, there's different approaches. Don't think that's the only way that you can do that. There are alternatives. Okay, given a is log 2 and b is log 3, express each of the following in terms of a and b. So what we need to do is just be a bit careful and think of ways of splitting these up. One way that you could tackle these is to prime factor these numbers. So if we look at 18, let's just consider 18. 18, we can divide this by 2, that's going to give me 9. We can divide this by 3, and that's going to give me 3. So I could write this now as log, and I'm going to use log. We can have 2 times by 3 times by 3, which is going to give me now, if we like, log 2 plus log 3 plus log 3, which is going to give me, and I'll do it step by step, log 3 plus log 3. That's one way that we could attack this. So what we've got then is log 2, which is a, plus 2 now b. So we've got a plus 2b. An alternative would be to write this now as log of 2 multiplied by 3 squared. And again, we could use the power law. So we'd have log 2 plus log 3 squared, bring the power down, and we could write that as a plus 2b. So if we look at this one, this now we could again prime factor 96. So if you prime factor 96, and maybe a slightly quicker way to do this, we would have now 2, we would have 48, we would have 2, we'd have 24, we'd have 2, which gives me 12, 2, we have 6, 2, and 3. So what we have here is the following. We have, and I'll write this as log, and then we're going to have 2 to the power of 5 multiplied by 3. So I can write this as log 2 to the power of 5 plus log 3. Bringing the power down, now I have 5 log 2. So 5 log 2 plus log 3. I know that log 2 is a, so I get 5a plus b. So that's one approach that you could take. Okay, let's look at this one right here. We've got now 9 over 16. I could write this as log of now, just considering what we've got, 3 and 9, we could write this as 3 squared, and then we'll divide this by now 4 to the power of 2. 2 to the power of 4. So 2 to the power of 4. So what I have here is now log of 3 squared minus log of 2 to the power of 4. So if I consider now, I've got 2 log 3 minus 4 log 2. So this is going to give me 2b minus 4a. Or if you like, 2, the quantity b minus 2a. If you want to factor it. Certainly don't need to, but that might help you out. Okay, let's look at some others. So if we look at the next one, one thing we could do with this, if we just look at this, I'm just thinking out loud, is we could write this now as log of 6 over 8. 6 over 8 is 3 over 4. This will give me now a log of 3 over 2 squared. So we can say that this could be now log 3 minus log 2 squared. And then we're going to have, this is going to be b minus 2a. Is there a quicker way of doing that? I'm looking at that thinking, yes, there could be. Yeah, we could do that a slightly different way, but again, that's entirely up to you on how you want to do that one. Let's look at this one. First thing I'm going to do is write this now as log of 6 to the 1/2 power. 1/2 log 6, 1/2 log, and just writing this now as 2 multiplied by 3. So we got 1/2, then we would have now log 2 plus log 3, and then we would end up now with 1/2 the quantity a plus b. So again, is there a quicker way of doing that? There might well be. I'm just looking at these and doing them as I go. So if we look at this one now, I'm going to write this as, and we could do this now as 3 over 2 log, and I'm going to write this as a power of 2. So this is going to be 2 to the power of 4. So all I've written is 16 as 2 to the power of 4, plus 1/2, and then we're going to have log, and this is 3 to the power of 4. 81 is 3 to the power of 4. So this is another approach. So if I multiply down, I'm going to have 6 log 2. That's just using the power law. 4 times 3 over 2 is going to give me 6, plus multiplying down, that's going to give me 2 log 3. So that will give me 6a plus 2b. And again, you can factor that if you wish. So there we go, that's given us some idea on how we can do this. Again, with this one, you might want to, let's just look at this one. So what we're going to have, let's do the next one. We got 4 log 3, then minus 3 lots, and I'm just thinking about this one now. We're going to write this as log, 3 lots of log, don't need the brackets here, let's get rid of those, and then we're going to have 2 multiplied by 3. So we've got 4 log 3 minus now 3 log 2 minus 3 log 3. That looks pretty good. Let's just consider this, just check that I've got this right. I know that I can write 6 as 2 times 3, which is log 2 plus log 3. I've got minus now 3 lots of that. So what's that going to leave me? That's going to leave me log 3 minus 3 log 2. So let's write this now. This is going to be, so what's that? B minus 3a. So do check that one. I'm just thinking out loud, but that gives us some idea. So we're just splitting those up and rewriting them. And again, lots of different approaches. Okay, without choosing a calculator, evaluate each of these. Okay, so let's look at what we've got. Let's go ahead and bring now the power up. So what I'm going to have is log to the base 5 of 1000 to the 1/3 power. I'm just going to write that as 10. In an exam, I would show full workings. This one I'm going to write as log to the base 5 and bringing the power up 4 to the half power, which is 2. I've now got a difference, so I can write this as log to the base 5 of 10 divided by 2, and I'll show that step. So we have log to the base 5 of 5, which of course is 1. So using now power laws, I've brought the powers back up. It's entirely up to you. Well, I say entirely up to you in terms of the way in which you manipulate these. Okay, let's have a go at the next one. Let's bring that power up. So this will be log to the base 12 of 4 squared, which is 16, plus now log to the base 12 of 81 to the half. So log to the base 12 of 81 to the half. The half power of 81 is going to be 9. This is going to work out nice. Log to the base 12 of 16 multiplied by 9. So log to the base 12 of 144. And that is going to give us now, what power is 12 raised by to get 144? The answer is 2. So we've just now used log laws on that particular one. Let's have a look at this one. So what we're going to do is just multiply. So this is going to be now log to the base 4 of 12 multiplied by 2/3. So what's that going to give me? That's going to give me log to the base 4 of 8. What power is 4 raised by to get 8? We take the square root and we cube, so we say 3/2. Or if you like, 4 to the x is equal to 8. We could say 2 squared to the power of x is equal to 2 cubed. So we could say that 2x is equal to 3, and then we could say that x is equal to 3/2. Entirely up to you if you don't spot those powers. I think that's a little long-winded. Okay, now we need to be a bit careful with this one. The trap to fall into is just saying, well, log to the base 7 of 81 over log to the base 7 of 3 must be now log to the base 7 of 81 over 3. That's not the case. We know that if we got a quotient, it's as a result of a subtraction. But let's rewrite this. What we can write is log to the base 7 of 3 to the power of 4. That is 81. 3 to the power of 4 is 81 over log to the base 7 of 3. So bringing the power law down, what we actually have here is nice and straightforward. 4 lots of this quantity, log to the base 7 of 3 over log to the base 7 of 3. That is a numeric value, so that's going to give us 4/1, which is 4. So that's one approach. Again, I'm not suggesting it's the only way that you can do that, but it's an option for you. Okay, let's move on to this one here. This looks a bit of a mess. What I'm going to do is just write this now as log to the base 27 of 12 to the power of 3. So I'm just going to bring the power up. Minus log to the base 27 now of 72 squared. So I can write this now as log to the base 27 of now 12 cubed. And I'm just thinking of ways of writing this. I could write this as 12 times by 12 times by 12. And then I've got now 72 squared. So I could write this now as 6 times by 6 times by 12 times by 12. I'm kind of thinking out loud here on ways that I could approach this. So I can cancel these 12 by 12s. Then I'm going to have now log to the base 27 of 12 over 36. 12 over 36 is going to be 1 over 3. So we want now 27 to what power is going to be equal to 1/3. So that's going to give me now negative, what's that going to be? Negative 1/3. Let's write that in. I'm just looking at that thinking to myself, is there an easier way to do that? I'm going to leave that one out there for you to decide. Entirely up to you on how you want to think about that. For me, that would be a good approach. So if you want to say the exponential equivalent, 27 to the power of x is equal to now 1/3 or 3 to the power of minus 1. So 3 cubed now to the power of x is equal to 3 to the minus 1. So we can see that 3x is equal to minus 1. And then we've got now that x is equal to minus 1/3. I'm just thinking of slicker ways of doing that, but to me that seems fairly logical. 12 cubed, 12 times 12 times 12. 72 squared is going to be 6 times 12 times 6 times 12. And then just cancel off. But as stated, I'm open to other suggestions on that. Okay, let's do this last one. So what we've got is log to the base 11 of 25 over log to the base 11 of 1/5. I'm just going to write this, and I'm going to write this as log to the base 11 now of 5 to the power of 2. Divided by log to the base 11 now of 5 to the power of minus 1. So just rewriting these as powers. So we have 2 log to the base 11 of 5 over now minus log to the base 11 of 5. So using my power laws, I can rewrite that. So we can see that that is just a quantity. That's a numeric value. So the answer is going to be minus 2/1 or minus 2. I'm still looking back at this thinking there probably is a better way to do it, but hopefully you understand of the different approaches. Okay, we're asked to express in the form log to the base 2 of the f of x. So all we want is a function of x. I don't want any coefficient or any value of x out front. I just want now something that I can write where I've got log to the base 2 of something now involving a term in x or x squared, something along those lines. So let's reverse the power law. For this one, we will bring now the 5 back up. So we'll have x to the 5th. So we can say the f of x in this particular case would be x to the 5th. So that's all it's asking us to do. What we have here now is a sum, so we can write this as a product. So log to the base 2 of x multiplied by x plus 4. So we could say now that our function of x is just going to be x plus 4. If you wish, you can multiply that out. I think it's better just left like so. Okay, let's now reverse the power laws. So we've got now log to the base 2 of x squared plus, and then we're going to reverse the power law. So all we're going to do is bring that 1/5 back up. So if we consider doing that, that's going to give me now, we're going to just have log to the base 2 of x. We've now got a sum, so we can write this as log to the base 2 of x squared multiplied by x, which is going to give us log to the base 2 of x cubed. So our function of x is just x cubed. Okay, we'll quickly go through these, bringing the power law up. So log to the base 2 of the quantity x minus 2 cubed minus log to the base 2 of x to the power 4. We've got a difference, so log to the base 2 of the quantity x minus 2 all cubed divided by x to the power of 4. So all we're doing is rewriting that. This one here, we would have now the following. And this is, I suppose they're just trying to, I'd say, trying to be clever with this one. It's actually quite nice. X squared minus 1 over x plus 1. The numerator is a difference of squares, so we'd have log to the base 2 of x plus 1 over x minus 1 over x plus 1. We've got now that the x plus 1s cancel, so our function of x is just x minus 1. With this one, it's just now reversing the power law. So that would become now bringing the power up 4 to the half, which is 2. Then we bring the power up and just combine. Okay, so there's some examples now of expressing in the form log to the base 2 of the f of x. So all you're doing is using log laws. These can be really helpful, especially when we come on to solving equations. So there we go. That is now an introduction, on quite a lengthy one, to now log laws. So if we went way back, when we're looking at logs with the same base, if we add them, it becomes a product. If we subtract them, it becomes a quotient. We've looked at the power law. We also introduced the other two particular laws as a result of them being inverse functions. They are just pieces of information for you, especially if you get into some more tricky problems. We know log to the base a of a is equal to 1 and log to the base a of 1 is equal to 0. So when we come on to solving equations, you will look to employ a number of these rules when you want to find a solution.